Well, it's time to get all of that out of there. It's time for some electrical modifications. Hey guys, my name is AJ. This is Denise and Allie. Welcome to the adventure we call life.
Get along on down the road. We got a long, long way to go. Scared to live, scared to die. We ain't perfect, but we try. Get along while we can. Always give love the upper hand. Paint a wall, learn to dance. Call your mom, buy a boat.
One really cool thing about the Volvos, to tell you the truth, is unclip a little strap right here. That's your stop. And then you just take the door and you go boop, just like that. Makes it real nice to get all that stuff out of your way, for sure. All right, grab some tools, get all that out of there. Yeah, I know I'm blocking the camera. Hold on just a second. I'll get y'all up in here to show you exactly what's going on. All right, so it's 4 batteries total, and there's just some big copper bus bars that run between the 4 batteries. I'll get you up there closer, and it's just a whole slew of nuts and stuff that holds everything together. So we got all that off, and we'll get all the wiring pulled off right quick, and then we will hop you guys up there and show you exactly what's going on. Let's go for a ride. Okay, so we got all the nuts off. Like I showed you, we got all the cables off, and here are those copper bus bars. They just run between all 4 batteries here. They're in parallel. There's one for the ground side, and then there's another one back here for the hot side. So anyways, we're going to get these off, and we're going to take them in there and get them all cleaned up, and we'll get all the batteries drug out. And once we get the bars all cleaned up, we're going to just connect them all back together in the shop, and we're going to put the battery charger on there, and we're just going to set it for like a 2 amp, so they'll do a really long, slow charge on them, and we'll evaluate and analyze all the batteries and make sure everything is good. But anyways, we're going to get all that stuff drug out of there right quick and get on with this show. Makes it real nice with that fairing out of the way. Be able to get right up in here, and these dudes are not light. Alrighty, so we got all the batteries out of the truck, and we did a little bit of wire cleanup already. I found a few more things again that I think were drawing power off of the batteries, even when the truck is like sitting here powered down. So essentially what had happened was there was a few things that were wired directly to the battery, and again, one of those is the trailer brake controller, which I don't understand why they did that. It doesn't need to be powered up if you got the truck turned off. I don't get that. Now I think one of the wires may be for the charging pin to the, like, your auxiliary trailer charging, and again, I didn't have any problem with that being changed over so it's on the downstream side of the cutoff switch. Again, if we're stopped and parked, I don't want the truck tied to the trailer necessarily. So we have got that all cleaned up and broken down now to where all we have left are these basic wires right here, which this is the main hot wire, okay? And then these are all grounds, all right? So our main hot goes to our battery disconnect and then out to the systems on the truck. So now we have just a couple of wires that are going to be connected to the actual batteries directly. The only other wires that were connected to the battery directly, no, it wasn't. It was through the cutoff switch, was the wires that go to the inverter. This is the main ground and the main hot that went to the inverter in the truck. This wires I'm going to reuse because they are substantial size, and we really want the biggest wire that we can get away with. So we're going to pull all this out and we're going to reuse it, but instead of it coming here to the batteries, we are going to install an auxiliary battery system way deep up inside of there so that we can separate all of essentially the house systems off the truck systems, basically like an RV. So we're going to have a house battery set up. We're going to have a chassis battery set up. So when we're traveling, we stop at night, we can power the truck off if we need to, and we'll have our own battery source back here to keep our inverters going, the refrigerator, some lighting inside there. I'm going to rewire the plugs again, the AC plugs, we already talked about that, so that we can have power to everything in here at night, the TV, the microwave, and all that stuff, where we're not drawing off of the chassis on the truck. So temporarily, what we're going to do is get some light going on here so we can shed some light on the subject. This is, I think it's called the jackalope. This is where they take the HD commercial truck wiring for your trailer systems. They run it through here. It does a lot of magical stuff, and it converts it into a standard like 7-way RV style plug. Anyways, we did some wiring cleanup on that already. They had all of these wires, this one and whatever. Anyway, they were outside of here. I'm sorry, focus. Anyway, they were outside of the main through plug, so we pulled that all apart, took the connections loose, got everything through the bulkhead terminals and good and tight again. Okay, so here's what we're going to do for the auxiliary battery system. Again, the inverter cables, well, they come up inside of here. They're inside the truck. We're going to reuse that. And this little space we have going on way back here is just kind of a little small crawl space, but it is perfect for some batteries to sit back in there. And it's kind of hard to reach, like if you have stuff stored in there. So we're going to utilize that as our battery storage area. This compartment is not airtight by no means, so there's ventilation in here if we were to use a liquid type battery, which we are not. But temporarily, we're going to use these big AGMs right here. Now, this is a 900 cold cranking amp AGM battery. It has a lot of power in it for starting. It's not the practical use really for what we're going to use it for, but it's going to work, okay? Because this is temporary. So I've got 2 of these. Even with the size of the battery that this is, the reserve capacity in it, like amp hour usage, is only about 100 amp hours. But I have 2, so we're going to have about 200 amp hours. But remember, this is a conventional type battery, and you can only use about 50% of that. So we're only going to have about 100 amp hours. Again, it's fine. We're not running nowhere near the amount of systems like it was in the motorhome. So I'm going to use these to mock everything up, to build the cabling and all that stuff like that. And they fit perfectly right in that space. So once we get them tucked up in there, we can build some stops on each side, keep them from moving around, everything like that. I have ordered a 315 amp hour lithium battery. Again, I'm going to build my own batteries because it's just way cheaper. I think it was about $246 for the lithium, and these are $180 a piece. I have 2 of them. But I have plans to utilize these so it's not a waste. See, everything gets used. But we're going to use these batteries. I have 2. We're going to get that mocked up in there so we can start building our cables. And again, as far as the inverter cables go, we're going to pull these cables out of the truck and we're going to utilize them in here to go back to our inverter because I'm going to change where that's mounted at. So the trick behind that is we really want the cabling to be as short as possible. So the closer you can get like your inverter, your DC power to it, the better off you are. And it was a long run, essentially from where the inverter was down to the main truck batteries. And I did do a 1200 watt draw on the inverter, and as soon as it kicked on, it pulled the voltage down on the inverter to 11.8 volts because the battery, the cable run is too long for the size cable. Probably could have went up to the next size cable and it would help a lot. Again, we want the cables as short as possible. So that's why we're going to put our power source right near our inverter. Now the cable that I'm going to be using is this cable right here, which this is really cool stuff. You can actually make jumper cables out of this because it's double leads like that. Anyway, this is a number 2 cable. This cable right here is good at 50 feet. It will still be rated for 200 amps DC. 50 feet, okay? So as the distance goes down, the amperage is going to go up. Even at 75 foot run on that, it is still good for 160 amps DC. So you see there's a lot of current can be carried through that wire. So that's what we're going to use, because again, our leads, our longest one is probably going to be about 3 foot. So essentially we would probably be able to draw about 400 amps DC through that cable. Plenty. We will never ever draw that much off of it. So what I'm going to do for now is I'm going to get the batteries kind of mocked up how we want them. I'm going to start getting some cabling laid out. I'm going to hop up inside the truck, and let's show y'all what's going on in there with everything we got tore apart already, and kind of the plan from that point. See right there, our battery is right there in the floor access. So, and this is the inverter that was in the truck. We're going to reuse it. It is a really nice inverter. It's a pure sine, 1500 watt continuous. And like I say, I did a 1200 watt draw on it. I also did a 1500 watt draw on it, and it didn't even flinch, even though the voltage dropped to 11.8 volts. We're going to fix that. This thing has some pretty serious lugs on it. So again, when we get that cable real short, we're not going to have any problems with that inverter. My plan is, so let's talk about this a little bit. This isn't designed, it is an RV. I mean, it has all the comforts that you need, but you know, it's not meant to stay in for weeks at a time. But when we're on the road, this is going to be plenty for what we need. I mean, we have a refrigerator, we have our microwave over here, we have a TV, I mean, we have lighting, we have everything we need, air conditioning, we'll have heat. So, I mean, for several days at a time, we'll be plenty comfortable in here. We can put one of the small composting toilets down there if we really want to, but again, I think we can be all right. There's plenty of places to use the bathroom. So anyway, I've got all the inverter, all the wiring torn out. I just got to get the cabling pulled through the floor, and we're going to start figuring out how we're going to lay out our inverter and our batteries. Again, our batteries are going to end up right here in the middle once we kind of push them through. So I've got to get some measurements inside there so we can build the stop plate over here. We can just slide the battery up against it, and then we can put a plate over here, and that'll keep the batteries from moving. They can't go this way because they fit exact, so we just need to keep them from moving this. So again, the plan is I'm going to get the refrigerator, slide it out. I need to find the cabling that goes to it. It is DC powered, but again, it is sourced off of the truck batteries. We're going to change that and source it off of the auxiliary batteries. And again, electrical AC current plugs are all isolated already through this little box. We're going to divide that out. We're going to run a couple off of the inverter, but then we're also going to run a leg completely separate, because I have one more little tidbit. Let's jump back outside and I'll show you that. This truck is rigged up to where you can plug the truck in off 115 volt AC. And that is what was originally powering all of the plugs inside the truck. So we're going to change this a little bit. So I got on that big gigantic store that everybody buys stuff from, Amazon, and I ordered a 50 amp plug. Okay, 30 amps is plenty. I get it, guys. Okay. We're going to set this truck up though. We're going to use 50 amp service. And the reason why is because we're going to take one leg, because essentially all 50 amp is 120 volt AC legs, right? Really not, anyways, you know how it works. So we're going to take one leg and we're going to power a bunch of the plugs and stuff in the truck. We're going to put a transfer switch in so that when we do plug in from the outside, we stop the inverter from drawing off the batteries. Well, from drawing off the batteries, we're going to put a pass-through system in there, changing that inverter out, right? So when we're plugged in, we'll pass through the inverter. When we're unplugged, we'll transfer the load over to the batteries. So we'll always have power. Anyways, I'm going to change it over to 50 amp. So we're going to have one leg doing that, and I'm going to have one leg dedicated to maybe one electrical outlet, but that leg is also, we'll be using transfer switches, okay? That leg is also going to be going to, my good buddy Robert was over here just a little bit ago, and we were talking about, we're going to do a mini split for the sleeping living area essentially. So I want that system to be able to power that. If we're plugged in somewhere 50 amp, we can just run that separately off its own leg. Or we can do a 30 to 50 adapter and it will still run everything just fine. We're not going to have any loads in here that are high enough that we couldn't run technically off a 30 amp. But I just want to keep those systems separately. Anyways, he is an HVAC tech. And he has already found a couple of systems that we're kind of looking into very low current draw. That's the main thing. A lot of the big residential mini split systems do have a pretty good current draw. So we have found a couple that are pretty low. And again, we're not cooling and heating much area in here, so we don't need like this monstrous BTU rating, okay? Okay, so one other thing that I forgot to mention is if you are working with cables a lot, like I do. I mean, I work with a lot of cabling in my job, but also just on my own projects and stuff like that. You absolutely need to invest in a hydraulic crimping tool. It will make your life so much easier to have one. This kit that I bought was very inexpensive. I bought it on Amazon again. It goes all the way up to 4/0 cable. I mean, guys, that is a big jaw right there. That is a large cable. And I mean, you can see, I mean, we're already using a number 2 cable. I mean, see how big the jaw opening already is. So it will go up to a very large diameter cabling, also down very small. Anyways, it's an absolute must-have, especially if you're doing a lot of cabling like I do. Anyways, another thing that I also do is, you'll notice, even after I crimp the ends, I still go ahead and cover them in heat shrink. We have a good solid copper to copper crimp. However, even though it's going to be enclosed in a good environment, you know, moisture and stuff can still seep, you know, into there over time. So it's just something I do. I always go ahead and heat shrink them anyways. But again, if you're going to be messing with cabling, invest in a hydraulic crimping tool. You can thank me later. Okay, so something like that, just to get the batteries bridged together, because these are temporary. Because remember, we're going to be going to 1 lithium battery. So anyway, these are just temporary cables anyways to tie the 2 batteries together. But something like that. So yes, these terminals are very close together, but no, they cannot touch each other because the case of the battery is bigger than the distance between those 2 terminals. So don't freak out over that already. The other thing is once those are slid up in there and we get them, we get our mounts on each side of the battery, they can't move side to side at all. And to be frank, I mean, them things are well over 100 pounds a piece. They're not going to go anywhere. So anyway, something like that. So now what we're going to do is we're going to kind of get them kind of positioned a little bit up in there, and then we're going to work on getting the inverter cabling out and rerouting it over here to where we're going to mount our inverter. I still need to kind of figure out where I'm going to put the inverter actually. I'm still thinking it's going to go probably maybe inside this compartment, which is accessed from up here inside the cab of the truck. Or I may end up moving the inverter. I just don't know. I may end up moving the inverter right here. Again, we want our cable run between our battery terminal blocks and the inverter as short as possible. That way we can carry the highest amperage load possible, and it won't drop the battery voltage so hard. Now, the inverter cable does have a really large inline fuse, so all that is going to be fused, so don't worry about that. And then once we get the inverter mounted where we want it, then I'll start trying to figure out like some of the AC cabling from the inside, which again comes from right here. There is a power distribution center just right up inside this cabinet that I'm going to take apart and separate the cord out of for the circuits that are on the right side of the truck, which includes the microwave and some additional plugs. And then we can just wire that in to one of the outlets on the inverter so that that will be powered all the time. And then the additional run of plug that is in there on the driver's side of the truck, we're going to leave so that it's powered through this plug, which again, remember, is eventually going to become like an RV style plug out here that is also going to be going through a transfer switch. So if we're plugged into shore power, it'll run, you know, just off the cord off the side of the truck. Whereas once we get a generator installed, if we fire the generator up, the transfer switch will change over, and that circuit would be powered off the generator. So again, all this is just a temporary mock-up to try to figure out how we want to do it best. All right, so let's do a little bit of catching up here on the progress. So as you can see, the batteries slide right back in that space really nicely. We're just going to build a bracket that'll come off of here over to the battery. It'll keep it from sliding this way, and they fit almost exact with the width of this right here. So we'll do another one on the other side, keep them from moving. This is ultimately what we have ended with as far as cabling. So all the batteries are tied together, and this, well, let's start up here first off. This lead right here is our main source power for the inverter, and that is a fusible link in there, so it's really short run. So if anything goes wrong, bam, it'll be right there to kill the batteries. This is our main leads that are eventually going to be going. Man, that's a run-on, isn't it? These will eventually tie into the main system on the truck where the main batteries are, the shutoff switch, and all that. Let's talk about one little bit of thing that I forget to talk about. This is our main ground return, whatever you want to call it. This will be a very short lead that's going to go to this. This is a 500 amp battery shunt that is for a battery monitoring system. This we're going to mount up inside the cab of the truck. This right here is going to mount right over here next to the, oops, let me get up there, next to the fuse. Everything that goes in those batteries and out of those batteries will go through this monitoring system, through the shunt. So this main ground right here will be broken off. We'll tie it into this. Everything that gets connected to those batteries, return-wise, ground-wise, will go on the other side of the shunt. So if we're pulling power out of the battery or we're putting power into the battery, it has to go through the battery monitor. That way we can tell how much is in the batteries, what the voltage is, whether they're drawing on the batteries, whether it's charging the batteries, how much capacity is left, rated capacity, blah, 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 blah. All of that stuff. So essentially we will only have one ground wire or return wire from here to there connected to those batteries. This main hot cable is going to tie into the main chassis batteries. Now I was a little bit decided on whether or not I was going to tie those in downstream of the battery disconnect or just directly to the batteries. I think I'm going to go ahead and just tie them directly to the batteries, and for temporarily we're just going to install a battery disconnect inside there as well. That way when we are stopped or parked for long periods of time, we can go ahead and kill the truck power, but we have the ability to, we can either leave these tied to the main batteries or we can disconnect them. So the reason I was going to do that is I guess we get into a situation where we have like some low voltage or something like that. Either way we go, we can leave them tied together and share, you know, 4, 5, 6 batteries totally. And again, all of this is temporary. This is just a way to isolate the main batteries for the sleeper side from seeing the truck batteries. Once we go to the lithium battery, we will have a DC to DC charger installed, and that will be the battery isolation device essentially. If the truck is not running, those batteries will not see each other. The only time that they will see each other is when the truck is running and the voltage comes up. It has an automatic voltage sensing relay in the DC to DC. It will close and it will start charging this battery. So this is, again, is just temporary. A lot of the stuff, the wiring and stuff will all stay permanent wise. But again, making up the cabling and everything was strictly just to get it all made up. Those batteries are not going to stay. So that's where we're at now. I'm going to get the shunt mounted, get the return line cut and mounted to that, and then we're going to start running the cabling from there, the rest of this cabling from there, and get it tied back into the main truck. And then we can start getting all the batteries and stuff put back in the truck also. So that's where we're at. Okay, so after all of that and the magic of video editing, boom, there we are, all done. So we got our batteries tucked up in there. We've got our shunt installed for our battery monitoring system here. And of course our main fuse here going to the inverter. The additional wires still are just laying out here right now, which is these right here. And I'll have to get the side fairing off here and build the connections to tie those into the main batteries. I'll do that in just a little bit. Anyways, I wanted to show you, so we have our battery monitoring system plugged in here. And again, these batteries don't have a lot of capacity in them, even though there's 2 of them. So they are advertised at 98 amp hours each. So we have programmed it for 196 amp hours. We're holding 12.7 volts right now because, well, they're brand new and there's nothing tied to them just yet. Somewhere you can get into programming mode. I just never can remember how you do it. It's one of these 2 buttons. Come on. There we go. Okay, so capacity, we set it at 196. Our full voltage was set at 12.6 volts. Again, it's showing 12.7 right now, but there's nothing on it at all. And so that is going to be our resting voltage. We can adjust that a little bit later on. It may be closer to 12.5. And then our 0 voltage is 11.9. And at 11.9, it will start alarming. And if the battery gets to 11.4, it will automatically shut the shunt off so that you can no longer draw on the batteries. Again, these are adjustable, so we're just going to let it go like that for right now, just to see what it does and all that good stuff. So anyway, I'm going to hop up in the truck right quick and show you what we're going to do with this little jewel right here. So you can even set it to alarm at a certain amp hours. There's a lot of things that this little battery monitoring system does, but anyway, we're just going to leave it at that right now, and we'll exit back out of it. So anyways, 100% right now, and see 0 watts being drawn off of it, 0 amperage, because there's nothing tied to it just yet. Anyway, let's hop up here in the truck, and I'll show you a couple other things we're going to do right quick. Don't mind the mess. I've got tools strode everywhere. All right, let's grab the monitor, and it has a really long cord on it. Anyway, this whole panel right here comes out, and we're going to mount the monitor just right inside here, just like this. We'll run the cord down behind everything and get it back into there. So anyway, that's where we're going to mount that, so that it'll be permanent. And so that's where we're at for now. Next project is, well, get the monitor mounted, get the wiring ran down in there for it, and we're going to, I wish my light hadn't died in here just yet, but anyway, we're going to pull the power plug wires here off the junction box. This comes from the outside extension cord. We're going to pull the main, I'll call the main. We're going to pull the wire out here that goes to the other side of the truck, which is for the microwave and everything. And I bought some plugs. Anyway, somewhere up here I got some plugs. Let me show you what we got. I just bought some 15 amp plugs like this, and we're going to plug that circuit into the inverter, which we have remounted right here solid on the bulkhead. It was mounted on a piece of wood before, and I mean, these inverters need circulation around them. They do have cooling fins on the outside and they have a fan on the inside, but we mounted it to the metal plate here, so this will also act as a heat sink for the inverter. And then our main power for the inverter is right here. And so anyway, we can turn all that on and off, and we can control all the individual switches as well down here for the inverter. So that's where we're at for now, and we'll move on. We'll get the monitor mounted, like I say. We'll get those other additional cables ran down there to the main batteries, and then I'm going to slide the refrigerator out here and undo the voltage, the power and ground going to the refrigerator, and we're going to swap that over to be on the circuit with the batteries so that our refrigerator can run nonstop even when we have the truck cut off. just like that. All right, so we're gonna jump from the outside, from the inside back outside right quick before we continue with the battery monitor and all that inside stuff. And I'm gonna go ahead and get the batteries put back in the truck right quick because, well, we don't have no lights inside and it is getting kind of dark in there working my flashlight. So anyway, I've already slid the 4 batteries back up in there. We're gonna get the bus bars stuck back on there right quick and go ahead and get the fairing on there because, well, that's the steps to get in and out of the truck. So let's get all this stuff hooked back up right quick, put back together. We got our bus bars all cleaned up. They're just made out of copper. They're solid copper bus bars. And like I said, this thing has 4 batteries in it. And they're hooked in parallel, so our voltage stays the same, but our amperage essentially doubles for every battery that we're putting in there, as long as they're the same amperage, which all 4 of these are matching batteries. So we're just keeping our voltage the same, amperage goes up. And all right, so we did a lot of cleanup on the wiring again, so we're going to stagger these a little bit, but our main chassis battery here, our main chassis return, our main chassis ground, make sure all these lugs are pretty cleaned up. Let me grab some Scotch-Brite and some sandpaper right quick. I'm gonna go ahead and run across these ends just a little bit. Hang on, I'll be right back. All right, grab a little sanding disc here. Get our cable ends all cleaned up, good and nice and shiny. They're pretty clean, actually. Just never hurts to make sure that they're all really good and clean. Good contact. Any kind of corrosion in there at all will just limit your capabilities on your starting amperage and stuff like that. Makes it harder to draw. All right, so back to what we were talking about. Our main chassis return wire, our ground, and our main supply wire, the hot wire, we need to make sure that they come off of completely opposite ends of the parallel bars here. So essentially what we're doing is we want to draw the hot off of one end of the batteries and the ground off the other ends. And that helps divide the load more equally among the batteries. Or so I've always been told all my life, so that's just the way we're going to run with it. Now these secondary grounds, we can do whatever we want to with them. We can space them out, stick them all on the same return, whatever. It doesn't really matter. Anyways, we're going to get all these tightened back up right quick, and we will be right back. All right, so we got them all back in there. Got our bus bars back on. This is what I mean. This is our main supply voltage, and it's coming off of one end of the battery bank. And then this is our main return, our ground right here, and it's coming off the opposite end of the battery bank. Now, this hot post back here, and again, the opposite post over here, is where we are going to tie in our secondary battery line, which is right here that we've been working on. So we're going to split these cables off and just come right down in here like that. Our return will cut right here and go on over here, and then we'll send our supply voltage on over here to this terminal. And then that will tie in our main battery bank through our disconnect switch that we installed to the auxiliary batteries. That way, if we need to, we can isolate these batteries, or we can turn them on and we can have all 6 batteries tied together in the event of like a low voltage situation. And moving down the road, once we get our transfer switch in, generator installed, some more electrical junction boxes and everything like that, if we're on shore power, site power, or generator power, we'll be able to charge these batteries also while we're charging the house bank batteries. The only difference being is I would have to install, because we will have lithium in the house and traditional on the chassis, we can't charge those with the same profile. So I will have to install an auxiliary charger so that we can set it for the liquid lead acid batteries. And so there it is, all done, everything zipped up, tied up, connected, absolutely gorgeous. All right, so we got all the truck batteries hooked back up, and we got some power on in here now, so we can actually have some lights going on. And I wanted to show you something. So because the truck has systems that are going to draw voltage kind of all the time, other ECMs and all that stuff like that. So I'm going to switch our disconnect here from our main batteries over to our auxiliary batteries, and I'll show you what's going to happen here. Watch. You see we're drawing about, well, you see how fast the amperage is going down. That's because it's balancing the batteries out, and with the loads that are on the truck, it's going to be drawing on these batteries also. So you'll notice that the amperage is steadily going down because they're balancing out, and then you'll notice that the counter below the 100% is going up, and that's the number of hours until the batteries reach our 11 point, what do we set it at, 11.8 volts, 11.9 for our low voltage alarm. So as they balance out, you see it's going up. So now we have a little over 41 hours until they reach the low voltage. And that's simply because, like I say, the battery banks are balancing with each other. And so that amp load, I mean, we're drawing about 4.3736. It's going to slowly keep going down as they balance. But, you know, drawing 4 amps, I mean, that's really not much of nothing going on. There's, like I say, there's a lot of systems in the truck that are drawing power and everything like that. So anyways, that's our battery monitor, and you can see now, actually, I mean, we're even down lower. We're down to almost 4 amps now, and it's still going down. We will probably get down on into the 2s, I'm sure, before it's over with. So all it is the truck battery is drawing about 3.9 amps right now off our auxiliary batteries. Anyway, there you go. Battery monitors, they're really cool. All right, so there we have it. 1 battery monitor installed. So I haven't fully put this piece back in just yet because I think I'm going to utilize this light switch right here. I'm going to wire that in to where that is what is controlling all of these auxiliary backlights, and then we will wire the supply to that switch off of our main battery, off of our auxiliary battery bank rack here, so that we will have lights and stuff whenever the truck is shut down. All right, so it's just 3 simple little screws, 1 in the side, 2 in the bottom right there. The refrigerator actually sits in a track. It just pushes back in there, and it's got a hold down, a hold down, and a hold down. And there is the wiring harness. All it is 2 wires. We have a hot wire, which is the white with the orange stripe, and then the ground return is just the gray wire. So all we're going to do is we're going to unplug the connector right here. I can actually reach around behind here, and the wiring harness comes out right here on the other side. Right back here is where the wiring harness comes out. So what I'm going to do is I'm just going to unplug it. Oh, my light went out. I'm just going to unplug the harness, and I'm going to pull it back through, and then we're going to cut it, cap the ends of it off that came from the original truck chassis side, and we're going to build a new harness for it. We're going to route it right through our box and tie it right into our auxiliary batteries so that we can power the refrigerator without the truck being powered up. All right, well, you may not be able to see it on camera, but we are just going to take our digital volt ohm meter here, and we are going to confirm pretty much what we already know. We're just going to confirm the continuity of the supply going to the refrigerator. So as I suspected, the orange with the white tracer is the hot wire, and the gray is the ground. And so we can confirm that. All we got to do is switch our leads here off our voltmeter. We can reverse the polarity, and we now get a negative reading. So it's reading negative 12.2. So we know we have our leads switched around backwards. So I'm going to switch them again, the black to the ground, the red lead to the hot wire, and we are now going to read a positive voltage, 12.2. So again, we just want to make sure that we get our continuity correct, so whenever we tie our new harness in, that we get the positive to the positive and the negative to the negative. All right, so we've just got our factory connector here for the fridge, and the factory wire here is 16 gauge, so it's not a lot of current that's being drawn on the refrigerator. So we're just going to use this
14 gauge double cable that I have here. Way more obvious than what we need, especially with the factory only being 16, but I mean, it works fine. So we're just going to crimp it all together here and shrink that down. Sorry about the coughing, guys. I'm actually, strangely enough, getting over the flu. I don't normally get sick, honestly, but man, it got me this year for some reason pretty darn bad. Just like that. So once we got it all heat shrinked, we just rewrapped it, and there you go, one wiring harness. Time to route it. Alright, so we just slid the refrigerator in. Like I say, there's just a bolt right there. And then there are down there where it slides back into the track. Stick 3 bolts back in there, and boom, done. Alright, so here's our main harness now coming from the fridge, which is right here. So it just goes out the back and right back into the compartment under here where we have all the rest of our electrical. Now, I didn't actually make really a 12 volt block, so to say, really. So all we're going to do is, for now, we may just leave it like this. Anyways, all we're going to do is we're just going to capture our voltage and our ground off our main legs right here going to the inverter. Again, the refrigerator is such low current draw, it is going to have zero effect on the input for our inverter, and vice versa. The size of the cable that we use from the inverter and how short the run is to the main batteries back here, again, the refrigerator is not going to have any effect on the power draw going to the inverter. So we just put some eyes on there. We're just going to tie it into the lugs right here, and voila, we will have power to the refrigerator. Also, since all of this stuff is tying in downstream of our battery monitoring system that we had already installed, we will actually be able to measure the consumption of the actual refrigerator itself, since we don't have anything else hooked up right now except the inverter, and we're not actually using it. So we're going to leave the inverter turned off, hook the fridge up, and we'll see what the monitor says, and it's going to tell us what the power consumption is of the fridge. All right, so we got our DC hooked up down there on our main legs to power the refrigerator. And of course, we don't have anything else powered necessarily right now off our auxiliary batteries because I haven't changed the lighting or anything over, and our inverter is not on. So our battery monitoring system up here is actually reading 0 amps and 0 wattage being drawn off the batteries. So what we're going to do is we're going to flip the refrigerator on, and we're going to watch the battery monitoring system, and we're going to see how much power the refrigerator is actually drawing. So it goes from 0 to 6. We're just going to turn it on. I don't know, we'll turn it up to about 5 or so, and we'll let it run for a little while, and we'll see what it does. But it's already kicked on, so let's see what happens. All right, so our fridge just kicked on. Let's see what it gets up to. So it's a compressor type refrigerator, and the compressor is kicked on. Now I can hear it, it's up and running now. So the amperage is falling off, and then it just cycled right back off. There we go. So the highest that I've been watching it when it's just kind of at a constant run has been about 7 amps or so, which is fine. And based off of that consumption rate, we still had about 20 hours of battery capacity left. Now, we probably wouldn't really get 20 hours out of it because, again, we got conventional batteries. And so as the voltage on the batteries gets down closer to like 12.1 volts, which is where conventional batteries really just tank, because they're not linear like a lithium. They are more of a slope. So one disadvantage of running any kind of AGM, gel, liquid lead acid, whatever, any kind of conventional battery will not hold up to the superiority of a lithium battery. I don't care what anybody wants to argue with you about that. You can take that to the bank. And as cheap as lithium batteries are now, really it's not even worth not going to lithium, which we already are. Again, this was all set up just with those batteries so that we could get the cabling and everything working. But I checked again the other day, the supplier that I purchased batteries from on AliExpress, which is where I get them from. I bought all the lithium batteries for our motorhome came from AliExpress. I had zero problems. 300 to 315 amp hour was about $263. And you can get a really good Dali BMS for about $60. So really for just right around the $300 mark, again, if you kind of shop multiple places, you can build a 300 plus amp hour lithium battery that will last days compared to a conventional battery. Yes, there's a little more that goes into the charging side of it. Yes, you do have to have a DC to DC to isolate your batteries, blah, 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 blah. It's, again, I don't want to ever hear the argument about traditional batteries being better than lithium, because they're just not. So anyways, that is the first stages of us changing all the electrical over in the truck. Things coming down the road, again, I'm going to swap the lights over to where these are independent from the front. And again, we're just going to utilize this switch right here. I also have some LED strip lighting that we're going to add, probably like down here along the floors. They are dimmable, so even at night, we can set those way down just for some floor lighting, if you need to get up or anything during the middle of the night. And then, of course, we still have the whole entire rocking stereo system coming. I started digging out all the stuff in the garage the other day, and I was like, I cannot believe how much stuff we have left over from the day. So we're actually going to do like a classic Alpine system in here, man, back in the day, Little known fact is Denise and I used to be sponsored by Alpine USA way back in our days. We had a 2001 Super Crew that was pretty phenomenal. We went to SEMA with it and all kinds of stuff. Anyways, so I have Alpine head units and amps and speakers and stuff all piled up in the garage we never used. But that's another story for another day. So that concludes this segment. This video has been way too long already. I'm sorry to have drawn it out so long, but there's just so much information to cover about changing these systems over to where they're not dependent on each other. And it's not that we can't tie them together. I mean, we have a main battery disconnect on here. We can switch that over and boom, we can have 6 batteries tied in. So it's just not a problem. But thank you guys for coming along. Stage 1 of the electrical conversion. I appreciate it. Thanks for watching. Give us a thumbs up, a like, whatever. I will try to answer any questions I can for you. If you want to subscribe, I would really appreciate it, but no one can make you do that. That is entirely up to you. But I certainly would appreciate it because it helps us figure out that crazy algorithm called YouTube.
Okay, sorry about the funky sound thing going on there. When I cranked the truck up, the vibration, everything was picking up in the microphone and just jacked the audio all kinds of up. But anyways, you'll notice that the display is now blinking really slowly flashing green. That's because we are charging the batteries rather than discharging on the batteries. So the display is set up to where it will pulse slowly green as long as you are charging. There's a bunch of settings in there and stuff like that we can change, all the background lighting and everything like that. So again, we are in the positive right now. We're no longer discharging on the batteries. So we're taking on about 19 amps, 260 watts or so, 13.4 volts. Also, you'll notice that the timer now below the 100% mark is now counting down. Theoretically, that should be the time that is remaining for the batteries to fully charge. Now, again, our auxiliary batteries are already at 100%, 196 amp hours. But remember, we're tied in now with our main battery bank on the chassis also. So it is still taking on some amperage and stuff where I've had the lights and stuff running, as well as the truck just being powered up in general. But still, we're only taking about 17 amps into the batteries. Well, I failed also to point the camera down far enough there, but what I was trying to show was the little map light switch. I'm going to wire that up so that it can control the auxiliary lighting in the back here also off of the auxiliary batteries. But anyways, there you go. Stay tuned. More coming soon.